Today, we're going to understand a phenomenon that's got scientists completely on edge. We're tracking an unprecedented cosmic monster, a silent, invisible threat that's expanding as it hurtles toward Earth, and it's basically breaking every single rule we thought we knew about space weather.
But before we get into the heavy science of it all, I want you to just imagine something for a second. You're sitting at home, maybe scrolling on your phone, checking your bank balance, or trying to pull up a GPS route. And then, in the absolute blink of an eye, the mobile networks just die. Your banking apps won't load, the GPS totally loses its signal, and suddenly you have no idea how to navigate across town. The invisible digital threads holding our modern lives together just snap. So what could cause an instant global blackout like that? Well, to find the answer, we literally have to look up.
Section 1. The invisible cosmic threat.
This invisible threat originates from our closest and, honestly, most dangerous cosmic neighbor, the Sun. To really grasp the scale of what we're dealing with here, think about this distance, 150 million kilometers. Across that incredibly vast, dark expanse, a massive, fiery explosion just happened on our star's surface, and that eruption birthed the giant magnetic cloud that's currently heading our way.
The sheer energy behind this is almost impossible to wrap your head around. Every single second, the Sun is converting roughly 600 million tons of hydrogen into helium. 600 million tons every second. That constant, furious reaction generates the life-giving energy we rely on. But sometimes, that energy takes on a wildly uncontrollable, abnormal form. Okay, let's dive into this. The official scientific term for this fiery birth is a coronal mass ejection, or a CME. You can basically think of it as a massive burst where millions of tons of superheated plasma and intense magnetic energy are violently thrown from the Sun's outer layer, the corona, straight out into the void of space.
If that sounds a bit too academic, just think of it like a giant pressure cooker. Inside the Sun's corona, magnetic energy is continuously accumulating, building up this immense pressure. When that energy finally crosses its absolute limit, bam, the lid blows off. But instead of steam, this cosmic pressure cooker is violently ejecting millions of tons of scorching plasma and magnetic force out into our solar system.
Section 2, unpacking the 21% expansion. Now, what's really interesting about this anomaly is that normally, scientists are incredibly good at tracking these ejections. They know how to predict their behavior. But this time, nature threw us a massive curveball. While traveling through the vacuum of space toward Earth, this magnetic cloud completely defied expectations and expanded its size by 21%. It's kind of like a monster growing larger and more powerful while it's actively hunting its prey.
So why does this happen? How does a storm in space gather more energy long after it's left its source? Experts are scrambling for answers right now. Some theories suggest that other solar winds might have actually fed it additional energy. Or maybe the Sun's own magnetic field underwent a sudden, bizarre shift. It's a fascinating puzzle, and it proves that space isn't just some quiet, empty vacuum. It's a dynamic, living ocean of swirling currents and hidden forces. And a lot of this is likely tied to the Sun's natural rhythm. The Sun operates on a cycle that lasts roughly 11 years, and right now we are nearing the highly active phase of that cycle, the solar maximum. This means we're going to see a lot more sunspots, an increase in solar flares, and generally much more turbulent cosmic weather. This 21% expansion we're seeing might just be a symptom of the shifting, highly volatile solar cycle.
Section 3. Risk to modern technology.
So, what does an expanding magnetic cloud actually mean for us down here on Earth? Well, if this supercharged cosmic storm breaches our planet's protective magnetic shield, it wouldn't just mean pretty auroras in the sky. Think about the systems caught right in the crosshairs. Our entire modern civilization is built on a really fragile network of satellites in space. A direct hit from a powerful magnetic cloud creates immense pressure on that infrastructure. We're talking about the potential paralysis of global banking systems, the total failure of GPS, which guides everything from your car to massive cargo ships, internet outages, disrupted air traffic control, and even severed military communications.
So the crucial point is, a severe solar storm is not just a minor tech glitch. If our satellites get knocked out, even for a few minutes, the global ripple effect would be absolutely devastating. Experts are warning that the resulting economic losses wouldn't just be in the billions. They could easily reach into the trillions of dollars, basically bringing the entire global economy to a standstill.
Section 4, the 1859 Carrington Warning.
If you think this is starting to sound like a sci-fi movie, history actually begs to differ. The contrast between our past and present is chilling.
Back in 1859, the world experienced a massive solar storm known as the Carrington Event. Back then, there were no satellites, no smartphones, no internet. The absolute peak of technology was the telegraph, yet the storm still wreaked havoc. Now contrast that low-tech era with our hyper-connected digital present. If a Carrington-level event struck our deeply vulnerable satellite networks today, the impact would be incomparably worse.
The sheer raw power of that 1859 event was shocking. When that solar storm hit, telegraph wires were literally throwing sparks. The electrical currents in the air were so strong that some telegraph machines kept sending messages even after they were completely disconnected from their power sources. Imagine that, unplugged machines just running like ghosts in the wires. Meanwhile, night skies across the globe were lit up with incredibly bright auroras. It is a really stark reminder that even humanity's best technology is incredibly fragile in the face of nature.
Section 5. Dangers for Mars missions.
And our vulnerability isn't just limited to Earth. As humanity prepares to take its next giant leap and travel to Mars, we face a massive hurdle. The contrast between Earth and deep space brilliantly illustrates this. Here on Earth, we survive because we're protected by a planetary magnetic shield. But once astronauts leave that protective bubble and travel through deep space in transit, they are entirely exposed.
There's a saying among scientists, on a journey to Mars, the greatest enemy isn't a lack of oxygen or food, but the sun itself. An expanding, totally unpredictable magnetic cloud of solar radiation is quite literally a life or death threat for astronauts in transit. If we can't accurately predict the mood swings of the sun or figure out the behavior of these 21% anomalies, our dreams of colonizing other planets could be stopped dead in their tracks.
And this is exactly why space weather is no longer just some niche scientific interest. It is a critical geopolitical issue. Major global powers like the US, India, Europe, and Japan have elevated space weather emergency plans to the level of national security priorities. We are essentially entering what scientists call the golden age of space weather tracking. We're treating solar threats with the exact same urgency as military threats, because the battlefield of the future isn't just on land or sea, but up in orbit.
The more data we collect, the more mysteries the universe throws right back at us. The 21% expansion of this magnetic cloud is a really humbling reminder of our place in the cosmos. We've built this entire world that is incredibly reliant on delicate technology suspended in the harsh vacuum of space. So, as we wrap up today's explainer, I want to leave you with this to ponder. Has our rapid technological advancement outpaced our defenses against nature? As we look up at the sun that gives us life, we really have to wonder when it might decide to remind us just how small we truly are.